Welcome back to class. The lecture today is going to continue on plumbing, and I hope we finish it off in this lecture and move on to some more components and systems in mechanical electrical plumbing. So today's lecture is titled Plumbing, Fixtures, and ADA. It's really the details of what we're going to go to. Let's jump right in. So these are the things we're going to be looking at, different fixtures and appliances and for plumbing. And then we're going to look deeper at ADA. I talked about this a little bit ago. I brought up this graphic, and this is a graphic from an architectural set. And we'll bring up the architectural set and try and find some of this stuff. But do you see this circle right here? That's the turnaround space required for ADA compliance. And maybe just start off, I'm sure almost everybody knows somebody with some sort of mobility issue, but it's close to home for me. My wife's father is somebody that really takes advantage of this, the things provided, the requirements provided in ADA. So it matters. Sometimes folks feel like and even I at times feel like, oh man, we just got hammered on ADA, but it's for a worthwhile reason to have these standards, and so we'll get into more detail there. But let's start with water closets, and we're going to spend a little bit of time here. So I think we went through in another lecture the submittals and showed a little bit of these, but this whole lecture is just going to try and cruise through a bunch of plumbing, like I said, plumbing fixtures and appliances and things. So obviously we all know what a water closet's for. It's made up of vitreous china as ceramic, right? And it's fired at a high temperature. And then, so stuff I don't know that I've ever talked about is that water closets are rated at 6 fixture units. And we mentioned that a while ago, and that the fixture unit is something that when you look at it in the code book, and there's no design necessarily for plumbing size, and the plumber has to size it, calculates it off of fixture units. But if you had one water closet, the minimum would be 3-inch waist and a 2-inch vent. And depending on which style of whether you had a flush tank or a flush-o-meter, it would change the water, the potable water side. And so let's say these are the two most common. Is you have some that are floor set and some that are wall hung. Wall hung has brackets here, and so this is all stuff that needs to be coordinated. If there's hangers and stuff, there needs to be space in the wall for hangers. A lot of times these are in commercial buildings, so you don't see these too often in residential, but I have seen them in residential. But the backing stuff is critical here. When it's floor mounted, you get one shot pretty much at getting the plumbing right, because you're going to place a floor, so the layout is critical when you do that. So it's worthwhile establishing where the wall lines are, and if it's going to be in a concrete floor or something like that, it's going to be hard to move after you place that concrete. A lot of work. So we got to get it right. So this might be super obvious, and I hope it is, because that's what I hope it's obvious. There's an elongated bowl and a round front bowl. But if it's not super obvious, this is the class for that, because sometimes I over communicate way too much. And so those are some common types. And then we're looking at a basic siphon type. And so let's just jump into that. I mean, I don't think this is super important to look at, like knowing that this is the bowl. I never really had a meeting where we were talking about the bowl of a water closet, right? So, or the flush rim or the water spot. But you can see what they are. I mean, there's some science behind it. I think it's worthwhile. You can see like this little jet right here to help it get the water moving. So we'll look at this in more detail. Let's do that. All right. So the siphon remember water seeks its own level, right? So as the bowl fills up, you see, like I was just talking about the jet. The jet's going to help the water get moving, and the bowl's going to fill up to a point where uh, it's going to push a lot more water this way, and it's going to fill up this space, and it's going to create, as the water level rises over here, it's going to create a siphoning action. It's going to pull water out until there's so much that like the air starts to enter into this, and then it'll uh, some water will come back in. But that we talked about scouring a pipe and having enough flow to move the solids along. Very similar idea with this as well. And then you can see the trap as well. So I think it's maybe you can see it right here pretty well where the trap in the the water closet is there so that the sewer gases don't come back in. And so it's got a built-in trap. So on the after a water closet, you don't have a trap usually. All right, so we've got just a flush tank here. Pretty common little setup for a residential environment there. Got the tank filling up. You got a little float shutting off the valve that fills the tank. A little rubber flapper that gets pulled up by the handle, right? And then the siphoning effect that we just talked about. Nothing too complicated there, I hope. When we talk about the wall-mounted ones, there's a couple different styles, but this is pretty common here, where you have a flushometer type water supply to this water closet. I always want to call it a toilet. I mean, maybe you should. Who knows? But you can see the jet right here pushing the water. It's going to try and move this along. Gravity's going to help it by filling this part of the bowl up, move this along. You can see, kind of hope you can see how that goes. You got water coming out the rim to try and scour or clean the bowl, and then the jet that way. I kind of already talked about this, but this is a little bit better view of like the float and a different type of float. So this one's got a float where it's traveling along this plane right here, and you can kind of see like this hook action. If you don't know what this looks like, go to your house or your apartment or wherever you live and go look at the tank. I haven't seen these installed very often, but they used to be really popular. I don't know if they still are or not, but they have a pressure flush, and I think the idea is that it does less water, so it'll scour your bowl and kind of the same siphoning bowl for residential, but it's supposed to have a little more pressure and help clean the bowl. I don't know if I don't know. Maybe it works, maybe it doesn't. Who knows? I haven't seen them very often, but they do exist. So we brought this up in I think the submittals. So this is a section cut through the flushometer, and hopefully you've seen these in commercial buildings where you have the handle, but you can kind of see that any way you move this handle, it's going to adjust the relief valve, and it's going to allow water in, and it's got a lot more water volume coming in a short distance than the like I think this requires like a 1 inch line or something like that to it, a 1 inch water line, where a regular toilet would be just fine with like a 1/2 inch line. So little cut section. I don't know. Again, I've ever really been in a meeting talking about the lower chamber of the flushometer or trying to coordinate anything with this other than to know a little bit about it. That's about all I know. But all different kinds of urinals, and we have like if you see the plumbing schedule, talk about a stall. They're talking about this kind. If you're seeing a wall hung with integral P trap, You've got wall hung with exposed P-trap and a trough, and there can be all kinds of different brands and styles and stuff. But I did like that this little graphic has like the basics, and that's worthwhile. Kind of the same thing. Closer up here, we have the flushometer type thing, but it's built into the back, or it's going to be up into the top. There's lots of different options here, and you can kind of see like where this is mounted up. You can't see the top one, but you can see that there. So this is definitely a wall mount, obviously, right? And got a trap in it, just like the water closet. The the fixture units that you'd have to have would be for if you just had one of these, you'd have to have a 2 inch integral trap and a 2 inch waste and a 1 1/4 vent pipe if you were just had one of these. Again, if you had a whole series of them, the pipe down line would have to get increased, but kind of give you an idea with just one of these what pipe would be there. Another urinal. This is a blowout urinal with you can read it, but I guess I shouldn't be doing that in PowerPoint. That's probably not a good. But the blowout urinals are flushed with a large jet of water. You kind of saw a cut section with the toilets previously. Okay, I think this is worthwhile knowing. This is pretty popular, and so if they're calling for a waterless urinal, and it contains a cartridge at the bottom, so there's no water supply to this urinal to flush the bowl or the urinal, right? And so what they have is uh, so that you don't have, forgive the crassness if this is crass, but waste sitting down here. What they have is like this floating liquid. Think of it like an oil, how oil rises. So uh, liquid waste would come in here and drop because it's heavier, and then kind of like find its way out because of the through this little drainage piping. And this is super popular in some buildings because there's no water that you're using to uh, flush the urinal. So it's going to save clients money in the long run. What happens if your bowl doesn't get, I'm going to use the word scoured or cleaned with a flush? Well, I think it might be obvious, but it's going to require some preventative maintenance. So some maybe additional cleaning that maybe you wouldn't expect as much on a traditional flush type urinal. But these are super popular, and if you're trying to be in a place like Arizona, even Utah, desert environment, this is a great thing to have, and it saves us a lot of water. Very good thing. I don't have it covered in here, but there's a term called gray water, and there's another system where they'll use water from the sink from washing your hands going, and the drains from the fixtures that we wash your hands in. So a sink, uh, it goes into a collection location separate from the sewer, and then they use that water and pipe it into like a urinal to flush a urinal. And so it's called gray water. And I don't have a diagram of it, but that's popular as well in some of the buildings. And you can get some points through lead with stuff like that. This is just a little diagram of from above, helicopter view, right? So we have the urinal here, the flushometer here, somebody using the urinal here, standing in front of it, and there's an infrared beam right there. And the plumber can adjust these a little bit. There's a little bit of adjustment to say how sensitive it's going to be. And one of the things that I thought this was useful, one is to understand that, okay, hey, it's infrared, but probably already knew that if you've gone to any restroom in the United States in the commercial world. So they're highly popular, and the point being, during construction and like punch listing time, folks can say, hey, this is in the commercial world. You know how they wear like vests and stuff, the reflective stripes on your vest. Well, those reflective stripes can can mess with these sensors, and you could be like 4 or 5 feet away and set this thing off with one of those vests, and then like the punch list, it'll show up on the punch list that this it needs to be adjusted, but the person doing the punch list had a vest on, and so it's not an accurate assessment of how sensitive the flushometer valve is with the infrared settings. Anyway, pretty interesting in my mind, getting punch list items on the the infrared beam. We got covered lavatories, but you can see a bunch of types here. We've got a raised back where you have sort of like uh, this part's raised a little bit, and you can have something more like a ledge or a pedestal. You can see this one has its own rim. You have under counter mount. They have a whole thing here where this whole vanity top is all part of the sink. So there's a bunch of different types, right? So a typical lavatory is one fixture unit. It would require an 1.25 inch P-trap, and typical water size coming to this, the minimum would be probably 1/4 inch. So I probably would never run a 1/4 inch to it, but I think that's the minimum. And these are all made of the vitreous china, the ceramic, right? So now we got a faucet diagram here, and you know how people can turn the faucet a little bit and it will then rotate. Anyway, so hard to try and describe this thing, how it works, but basically turning the handle a little bit to different ways, adjust this bottom thing, and so how this bottom part moves and adjusts to which port where hot and cold water is going to determine how much water and how much hot and how much cold and how open the valves are, all by turning and adjusting the handle, right? So if you had an integral handle with one handle coming out, right? Okay, well, I don't think that's super important, but that's what it is. I don't know if this is important either, but I've never been in a meeting where we're talking about this either, but I think it's worthwhile knowing how it works, even if it's just to try and get an idea for yourself of what it is. So you've got the faucet handles up here, and what's not shown is the lavatory bowl. A lot of times in residential you have this little this little rod that you can pull up, and it'll put a stopper down so that the lavatory can't, the lavatory can't fill up. So that's going down the back. The things that really have to be coordinated is this submittal information, which we've already talked about, going to the submittal information going to the countertop folks, and the lavatory size going to the folks doing the countertop as well. And then there's sometimes you have to have the spacing on these is what they need, and how many drilled holes through the countertop. What would this take? Well, that's going to be 3. This one's just 2 holes, right? So, well, it would have a third with that, but anyway, all different kinds of information that should be sent to the countertop folks. And these also have the infrared, and it's worthwhile to know that the extra money can be worthwhile, and that it's not, especially in this day and age where we're trying not to spread disease, the sensitivity there, that it can be very valuable to not have to touch anything. And so that's the idea there. And remember that tempered mixing valve that I talked about in another submittal. When we look through that submittal, that would be the case on this guy, because you can't adjust the handles. So that mixing valve down below is super important that it's set right so we don't burn or scald people. Now, bathtubs, I mean, I'm hoping people know all about this stuff, and this is just a real quick review, but I think it's worthwhile to know that there's all kinds of like a complete insert, shower tub insert, just a maybe just a basic bath shower. Then you have like a drop in here and freestanding, and there's all kinds, right? But the stuff that's important from my perspective is would we necessarily put floor tile underneath here? Probably not. Would we put floor tile underneath here? No, definitely not. And so knowing exactly what the insert is going to be definitely affects your floor finishes. Where in this environment, you would definitely need to count for all the tile that's going to be surrounding this area. But no, sometimes it's drawn really well, sometimes it's not. And so maybe this is more like a residential home and this isn't all been picked out, but then they end up specing this and well, shoot, we need to fill this whole area in with tile. We were planning for like more of a traditional bath like that. Wouldn't be a big deal, but just need something to coordinate. Coordination of framed walls is a big deal in these environments where these are all prefabricated units in these pictures, and there are some that I know that can be done with done to certain dimensions, which would be just fine with me. You can do that, but having these framed correctly, and then I mentioned it a long time ago about fire ratings, and for some reason it seems like the more often than not the restroom is next to a fire rated wall, and so uh, this behind here would all have to be pre-rocked, meaning you'd have to have drywall that's fire rated done behind this enclosure before this bath and shower assembly got installed because it's a fire rated assembly in a commercial world. And so and residential like apartments and stuff. So apartments, hotels, all kinds of things like that end up having fire ratings. Oh, excuse me. I don't know where that came from. I'm boring myself with bathtubs. But it is such a pain sometimes where we're talking about the fire ratings behind here, and it's missed so often that if the framing isn't done correctly, and then it requires certain layers of sheetrock for fire ratings, and then oh man, that was two layers of sheetrock, not one, and so this thing doesn't fit anymore because there's two layers of sheetrock all around it, not just one. So you just lost an inch and a quarter of from that side to that side and 5/8 on the back. So did that fit? No, not anymore. Or I've seen it before where there's been apartments and stuff where they've done like four layers of sheetrock to get the rating that they need between the occupancies, and so it was like normal rating between unit, normal rating between unit, normal rating between unit, and then it hit this uh, occupancy separation wall, and the occupancy separation wall was I don't know, a 3 hour wall or something like that rather than just a 2 hour wall, and so it needed additional layers of drywall. And it's sort of getting into that production mode where you're doing room after room after room, and then we don't think about the anomalous room down the road that one's the one that borders the occupancy separation, and so it's got a higher fire rating and more drywall. Got to pay attention to all that stuff. So, and if you don't want to go backwards, if you want to go, if you want your project to go consistently forward, not having major disruptions and rework, you got to be paying attention to these dimensions, especially when it comes to something like that or like this. Maybe not so much this one, and definitely this one's not a big deal. But again, something else to pay attention to stuff like this, where we build a high-end custom home. I've seen these freestanding tubs. It's quite popular to be made out of like a granite and or some other stone that's been carved out, and several thousand pounds. And so getting that several thousand pound tub or bath into the space, how are we going to do that? Well, it's not going to be picked up by a couple guys. It's going to have to be lifted in place through a forklift or something like that, or a crane or something like that. And so, how are you going to get it into the building? And when are you going to have it into the building? And what's the lead time in order to get it in the building so that you still have an opening? I remember one where guys really did a good job. I was really impressed with how they did it, but they rigged it and brought it right through a window. But that was some planning. That was pretty cool to have them do that. And then the detail of where the actual plumbing stubbed up and the detail layout for this in order for the tub to sit exactly right. And then how level was the tile? Well, if you have a really expensive tub and it's got a flat base, you can't have uneven tile all around it. So there's a bunch of things that the tolerances have to really change when it comes to more unique things. And so kind of the point of that. And got a different kind here where it'd be whirlpool bathtub and all different kinds of jets and things like that could be piped in and figured out. So I think that's worthwhile. And so we've got the bathtub faucets here, all different kinds. I don't know if I want to spend a lot of time. I think it's worthwhile telling you that there's all different kinds. You can see here that this is more like the mixing valve, and this one's more of a traditional valves here. And the idea here, again, you should be able to pull up on this little knob, and then it stops the water from coming down this and then travels up the pipe and out. And so there's the point that I would want to bring up is the valves and stuff all have to be installed prior to drywall. So this whole set of faucet assembly pieces here. If they're going to be in a wall, that's sort of an early thing to pick out, right? You got to decide, well, client wants single handle or the client wants this, but that's an early rough activity that this has to be installed in, and maybe this is not, maybe it's spec'd out like this, or maybe the client wants to go to that. Well, it's a lot of work to move from this to this after stuff has already been installed. So an early activity that need to plan for rough when it comes to stuff like this. So we've got a couple different scenarios here for a tub, and you can see like the drain coming here, and then it's got a little handle here that can stop this thing, right? It's also got the overflow fitting where on a tub, if it gets too high, the water is supposed to come down here and down so it doesn't spill out all on the floor and stuff. Now showers, they can be made out of anything. The tile, it could be fiberglass, it could be plastic, it could be marble, mincy marble, all kinds of stuff, right? But again, it's worthwhile seeing, okay, hey, we got a one piece or like a multi-piece thing here where excuse me, talking too much. Where the base goes in and then like the three sides come in and then it all gets silicone together, or anyway, it could be that, it could be just a base, it could be tile, and the tile would have to have a drainage mat underneath it and some other waterproofing elements behind it. All kinds of different options, but this is sort of the same thing that I was talking about with any built-in with the the fire ratings. Again, it seems like fire ratings are such a pain. They're not that hard, but if people aren't paying attention to them, this is again a perfect example where in an apartment complex or townhomes or something like that where you're sharing common walls, means you have a zero lot line, basically two residences backing up to each other. That means it's got to have a fire rated wall between them. And I don't know if it's fire rated as fire. I don't know what the right word is, but the wall would have a fire rating to it. And I think I'm saying that wrong. Occupancy separation wall, maybe? No. Seems like I'm saying that wrong. You're probably like, Michael, you said that wrong. Anyway, there's a fire rated wall there. And again, kind of the same thing. Well, is it two layers of sheetrock, one layer of sheetrock? And then it could be as easy as the framers not knowing the dimensions, or the framers not laying it out correctly and framing it correctly. So anytime walking through, specifically take time to know what these rough end dimensions are supposed to be and throw a tape on it and make sure right away that it's being done correctly. Don't want to come to the end of the job trying to fit this thing in place and we've got too many layers of drywall. It's happened to us too many times. It's no fun. You also have things like tempered glass that could be making this surround. Um, Sliding doors. I've seen sliding doors. All kinds of things that make a shower surround. So lots of different ways to make it. Again, the dimensions are critical. A lot of this stuff is prefabricated, so the dimensions are important. So we got the shower supply valves. Again, kind of the same point as I was making about the about the about the tub and having to know exactly what your rough in is going to be and having the valves installed during rough. And looking at my notes. Yeah, I don't think that there's anything major there that I wanted to talk about other than just, hey, there's lots of different kinds of shower supply valves, right? We all knew that. Then we got a bidet, and we have lots of questions on the in the quiz about the bidet, so really study up there. And we've got kitchen sink, a couple different ones shown here where we have a counter on the top and it's self-rimming, right? Have one under counter. And what we need to do for this setup right here, well, we definitely need to make sure that this product got over to the countertop folks so that they could build this exactly right along with these right here. And even though these are, seeing this kind of interesting as well, that it gets kind of popular to have some of these extra what look like drawer fronts right here and right here actually do something rather than just be fake. And so that's some coordination that ends up happening as well. And then usually you have doors here, but I've seen this be drawers as well. And those can be a challenge to make work, giving the plumber less room than he was planning. But kind of on the stainless steel one, this one here, think through that, how much coordination is required here. Well, this is all tile work, and which is a little bit of coordination, but from a prefabrication standpoint, the sink took care of all the prefabrication. So as long as we bought this assembly correctly, the faucet and the sink, pretty easy to get it done correctly. We got a bunch of different faucet setups. There's all kinds, right? We got I think this is just way too easy for you guys to think through, but I do want to show that there's different kinds, and it's super common to have to like work through with the client on these things, and it's important to their building or to their home or to the space, right? I mean, this is the fine touch detail stuff that really matters at the end of the day. And so paying attention to these and knowing that there's all different kinds of types, and maybe even getting spending a little bit of time sometimes to subscribe to different magazines just to be able to different builder magazines to be able to make sure that I'm trying to stay current with the current themes or styles and stuff. Uh, and so it can be a real challenge to stay up to speed on all this stuff. It changes pretty quickly, and so definitely the one thing that I would recommend is as you're trying to pay attention, if this is something that you have to deal with a lot, do pay attention, but know that a lot of the fixtures they have like a fabrication cycle and then a retooling. So say we're doing these in bulk on a multifamily home or something, a multifamily project, lots of apartments or lots of condos or something like that. The If I was trying to get these all delivered in bulk and I made the order in like December, but the design was done maybe previous year in maybe like November. So the design, when they picked out all this stuff, it was like a year old or more. And then I waited almost a year to order all this stuff. It's a good possibility that I'm not going to get enough of, or they have slightly changed, or they are retooling. So you got to pay attention to uh, these different faucets and fixtures and appliances, microwaves. It's true, ovens. It's true. The manufacturers kind of go through this cycle of production, and then they stop production and retool for the next batch, whatever it's going to change. And so if you're at the end of their production cycle and trying to order mass quantities, a lot of times they just don't have them. We've got a sink here with two drains in it, just trying to show exactly what it would look like. We got a disposal here, and we did a kitchen sink diagram, so it might be worthwhile paying attention to this one here because you're going to get an assignment to do that again in more detail. But take a look at this drawing here. So we've got a waste outlet, we've got a dishwasher connection. What this is drawn not schematically, so I'm not expecting to see this level of detail in a schematic. This is drawn really accurately, but what's it obviously missing? Well, obviously it's missing hot and cold water. It does show its waste outlet, but it's missing electricity for this thing too. So it's not drawn schematically. I'm not criticizing the graphic. I'm just saying think through this thing right here because it's on the kitchen sink, and the kitchen sink doesn't work without this working. And what's connected? Well, the dishwasher's connected, the waste is connected, hot and cold water's connected, and power, electricity. Multiple systems, multiple utilities needed to make this work. Let's just run through what would really be needed on the kitchen sink for the kitchen sink to work. Well, you need hot and cold water, so that's water, which is the water utility. You need power to make this work, so electrical utility. If you want the water to actually be hot, you need a source to make it hot. So it could be electrical water heater, it could be a gas water heater. But if it's gas, that's another utility. And then got a waste line right here, so that's another utility. So sewer. So you just think of your kitchen sink, how many things are connected to just make the kitchen sink function right? It's not just water and drain. I got the system here with both got one sink over here and one sink over there. I'm hoping that this is like super easy to understand. Just a different configuration. A couple different configurations on how the dishwasher has to be dishwasher drain line has to be connected. If it's going through a disposal, which I think in our region is almost every single time. If it's not, the dishwasher has to have this little thing in it right here. We're now into laundry units. So we have like a wall hung type, and we have a floor set, floor mount, sink. And there's lots of different kinds here, but it's worthwhile talking about. All right, made out of all different materials, right? I've seen it stainless steel, plastic, ceramic. If I said fiberglass, seen it as fiberglass. Lots of different kinds. And with that laundry, you're going to need a different setup for the faucet. A couple different options there. You can kind of see them. So just some different faucet options for laundry. So moving on to the washer and dryer, and this is a common setup here with a rough-in. You got the rough-in box here because the drywall is going to cover everything but this box. You got the cold water supply, hot water supply with kind of like a hose bib looking connection there. And then we've got a drain line, a 2-inch drain. So if this is just for the some when you have a washer dryer, some of the dryers actually have steam cycles on it. So if I was doing a high-end custom home, might put a third one in here just for that, rather than having so we could make those lines not look so messy in the back, or how that's all going to stack, the location of this so it's accessible, all different things that you need to consider so that the actual washer and dryer can actually fit in the space. So if the intent is to have the washer really close to this, or is the washer going to be far away, maybe this needs to be somewhere else. Maybe this is the only wall that it fits in, and so maybe you got to worry about the floor pan down below, moving that slightly so you can have room and access to this stuff. Just things to think about when not just slapping it wherever it fits within the studs, is put a little bit of thought, a little bit of coordination in. And again, if I was the plumber and general contractor didn't give me any information, I'd probably just put it wherever it fit with the studs. But a good general contractor trying to take care of the client would be trying to get that information to the plumber, and a good plumber would be asking for that information as well. But that doesn't always happen. So we've got this. So below grade floor drains must be equipped with a backwater valve. I saw that in the code in the book, and I have never seen this before. Did not know that was a code requirement. I wonder if it is. I wonder if this is an IRC or a UBC, Uniform Building Code, or I don't know. I mean, yeah, I don't know. I've never seen this be done like that. So maybe I've always done this wrong. I'll have to look at the code closer, see if I can find exactly where this is. But I found this in my plumbing book, and I thought it'd be worthwhile bringing it up since it was new to me. But you can see, like, if the water was backing up, this would be connected to the sewer. And if the sewer was backing up, it makes a whole lot of sense not to flood your basement and have that stopper there. For some reason, I have not seen that be installed ever, not once. Maybe it's been installed and I just didn't know. Could be. On this one, we've got a floor sink, and kind of got this idea of a grate here, and then got a little dome strainer there, and be able to connect, like the idea that these are in kitchens or other places where they're washing the floor a lot, but they want to be able to collect some of the finer particles and stuff, I don't know, waste, I don't know, whatever you want to call it, but like chops of food and stuff, so it doesn't clog up their sink or their drain line there. So these are coming in all different sizes. The floor sinks are. They're all different kinds of material. Typically, cast iron is super common. I haven't seen a lot of stainless, but I know that comes in that. I would say most of what I see is cast iron. Not too exciting on this topic. I'm sorry, but I do want you to know it. I think it's worthwhile. But I'm probably killing you here. Like you're probably just like dying because I'm having a hard time getting through this lecture here. I'm sorry, but I get it's worthwhile. It's not exciting to me at all, but maybe it is exciting. And hey, that's really cool. All these different types of things, and they're worthwhile to know. I've said that like 5 times now. It's worthwhile to know, and that's why I'm doing this lecture. But it's not. It's not terribly exciting to me. We've talked a lot about in other lectures about the different water coolers and drinking fountains and stuff. And again, it's all coordination. It's how are these going to lay out? Do we know where they go? And you can kind of see this picture's got a clean out on it. And do they require power? Do they not require power? This would definitely require power, right? Okay, we got service sink or a mop sink or janitor's, all stuff that goes in a janitor's closet. And if you're not familiar with the commercial world, that these are super common. And a lot of times you'll have uh, some sort of impermeable surface on the surrounding walls and stuff. And so depending on whether it's tile, whether it's like what's that stuff called? I want to call it GFRC, but that doesn't sound right. FRP, fiberglass uh, reinforced panel, I think. I can't remember. FRP. So there's a plastic sheet kind of stuff, fiberglass sheet that can go on the walls. Super common. So we're getting into the idea of water softeners, and I don't want to do a whole lot on things at a molecular level or atomic level. I think that yeah, okay, understand that there's a process going on inside uh, the water softener to get rid of the harder I don't know, get rid of those harder particles that are found in your water and make it better water. But there's all kinds of water softeners too, both for residential, commercial, industrial water softeners, depending on what you're trying to do. Know that it's got some process here. I'm never going to test on it. The Let's look at like a typical residential one here, and a lot of times you see like these 2 tank ones, and like they say a brine tank. This used to be filled up with salt, and so there's other kinds too where the they're saltless or anyway. This one's got a brine tank in it as well. This little diagram, but there's all different kinds, and I'm not really into knowing exactly what the best one is. I don't know that kind of stuff. Mostly I'm dealing with, okay, this is the one that's specified. I'm going to look up the product data and see what's required. Obviously, it's going to need power. Obviously, it's going to need a drain. Obviously, it's going to need a water source to it. And if I can verify that those things are there real quick, then we're in good shape and we'll go install that thing as long as there's space. So a little coordination of space, right? All different kinds of stuff there for how to condition your water. I think it's worthwhile to look at though the isolation for it. So being able to take this in and out of service and then having this um, bypass. So if you have like your water coming in and then you have to take this out of service or something, you need to bypass it. And so that's water coming in, you put this bypass in and water coming out, and shut both valves off. That's a worthwhile thing to pay attention to, making sure that that's available to the client. I don't know if it would get caught in an inspection or not, if the city would ever find it, but definitely worthwhile for your client. All right, we've got the water heater, and for some reason, this kind of stuff, to know how it works is more fascinating to me than like the plumbing fixtures. So it makes me smile to think through water heaters a little bit. But you've got water coming in and water coming out that's hot. And down at the bottom, you have some sort of burner. Maybe let's go to the other side. Yeah, that's a better view. And so we've got gas being burnt and trying to get the gas to sort of like move around more so that more surface area touches this. And so the more surface that it gets, maybe not the word turbulent, I don't know what the right word is, but they have a flue or a baffle usually that kind of moves the air around so that it's getting all the heat moved into the water from the fuel source. And so eventually that needs to go out of the house. There's a hot water out right here, cold water in. Um, there's an anode rod. You guys know what those are? So the what's the right word? So the idea behind the anode rod is basically that the water is going to try and eat up this water heater tank, and this is more of a sacrificial anode, and so the water eats this up, and this is, if you have you could actually replace these, I'm pretty sure, and extend the life of your water heater if you've had it for like 5 years and want to replace the anode rod to try and make sure that it has a sacrificial anode inside of it. Again, why the heck do you care? I mean, like, build this, and then for the client, you're not ever going to be the plumber to go back and take that out. But for some reason, I think that's interesting. The you have the pressure relief here as well. So this is going to go off, and usually it just gets to the floor, and this is right next to a drain. We've got the this thing right here controlling the flame, thermostat. You've got an igniter in this as well, somewhere over here. You got a drain. So there can be a lot of sediment as well get built up in water heaters. So these little drains, I wonder if you went to your house. I know I replaced one in my house, I don't know, 5 years ago. Tried to drain it, and you know what? It was draining so slow because there was a lot of sediment in the bottom of this valve, mostly filled up with sediment. Anyway, interesting because I think it's more dynamic. There's more stuff involved, and like some science stuff involved that I think is interesting. So for some reason, I like this. Who knows why? The one other thing that's not shown on this graphic is the combustion air. So it would need to have you don't necessarily, these are in a mechanical room or of a home or in the space of like a commercial building. Typically don't want to use combustion air from your home to as part of the air to help burn the fuel. So sometimes you have a combustion air duct right into this room. It's just an open duct, and sometimes they get fancy and put a automatic damper on it or some other things like that. But combustion air is a big deal as well. And we've got natural gas as the in this environment right here. This showing it's like it'd be a natural gas utility plus a water utility to make this work. Kind of a real cut through here of an electric water heater, and it's just a heating element uh, done with electricity rather than natural gas. Obviously, if you have a natural gas that supply is pretty readily available, you wouldn't want to do it with electric unless the electric source was super cheap relative to uh, the natural gas. And you can also do these in propane. But let's look at this piece. This is interesting to me, and I think I keep telling you what's interesting to me and what's not. Whatever. Sorry, but I think these are interesting. You see these in larger pieces like this inside of large commercial projects as well, and sometimes they can get really big on different systems where you have a really large expansion. They call it water hammer arrestor, but basically there's like a bladder in here and there's air, and so uh, it allows water to expand and contract a little bit. Anyway, kind of cool. And sometimes like this water hammer thing is like it's not necessary just for expansion and contraction, but maybe on and off valves fairly quickly. And water has mass to it, and so as water moves through its pipe, you gotta remember that's weight moving through a pipe. Water's not super light, and so you're sometimes you can hear that abrupt movement of water in a pipe, and so they use these to try and limit that, uh, limit like shock or shaking of the water pipes. And then we had that temperature relief valve showing, right? And so this little lever, you could open it manually, but there's a thermostat piston that if it gets too hot, this will expand and open and push up against this spring and allow water to come out. I guess out this way. Sorry. All right, we're into 88, and this is really important stuff from a commercial. I don't want to get to the end of my project and have to do rework. And it is super common to have ADA problems inside of a building. And so, not on a residential single family home, I don't even think ADA applies, pretty sure. But on multifamily type projects where you have like apartments or specifically hotel rooms or dormitories or things like that, uh, this becomes a big deal. And then also in the commercial world for any kind of building in the commercial building is going to have ADA compliant stuff. So let's do a little see if this will zoom in for me a little bit. Okay, so on this one we've got let's bring my laser pointer back up. Oh, it won't let me do both. All right. Well, you can see that the height of the the water closet matters. It has to be 17 to 19 in, uh, and I believe that's to, man, is that to the top of the seat or the bowl? I'll have to check that. I think it's to the seat. But there's this dimension that matters, the vertical dimension. Having space in front of the water closet matters. And then you can see like the center line of the toilet, 18 inches, 42 inches as well. Let me grab my ADA stuff. Cheat sheet. Highly recommend getting one if you have to. Hmm. It is to the seat, top of seat. So this 17 to 19 would have to include the seat as well. What I'm looking at is this little ADA accessibilities thing. I have a copy of the ADA stuff. You can get it off their website, but these little cheater things are really good to have. And so there's a lot of different spaces here that matter. The 18, they're listing it at 18. I thought it was a range. Yeah, it's 16 to 18, not just 18. So it could be within 16 to 18. And it has to be a minimum. You see how 18 plus 42 is equal 60? 60 inches across is the minimum, but this could be 16 to 18 right there, that dimension. So relative to where this toilet's sitting or this water closet's sitting, it matters. And I had a hotel that got inspected for ADA, and literally within like a quarter inch, no, you got to adjust that down a quarter inch so you're in ADA compliance. And I don't know that would really matter for somebody with mobility issues, but the point being, they give you a range of 48 inches here. They have 16 to 18 inches here, and you got to hit the range. So that's the range. And sometimes it can be really challenging where the floor height, say you set these water closets all at the same height, you have a whole bunch of them, and you set them all at the same height, but the floor is actually sloping to a drain or something like that, then you could be off. And so it matters. You got to pay attention to this stuff here. And then they're showing grab bars, the amount of space before you hit the next restroom stall, that kind of stuff. Let's go look at the next one. Here we are at the urinal. So the urinal, they're saying 24 max to the rim. Oh, yeah, that's standard. That's not ADA. This is the ADA one. So 17 inches to the rim is max for for ADA. Sorry, I was thinking that they were trying to say that was ADA. Didn't make any sense. And then you have to have that minimum floor space, and the flushometer has to be one handle or automatic. And the height to that is maximum 44 inches. So there's lots of stuff here. They don't give you the how far out from the wall. So the wall's here and how far out, but 13 and a half inches is the max there. And they have the minimum, I think I already said that, the minimum floor space. It's worthwhile knowing all this stuff. I'm going to show you in a set of drawings where to find this in a second. Now the lavatory, zoom in on that. We've got a standard thing over here at 31 to the top, but ADA is 34. And let me look at my cheat sheet here. Throat's getting dry from talking. Yeah, it's I got 29 to 34 on my cheat sheet. Oh, hey, they do have it. Okay, 29 to 34. So it matters a lot what lavatory gets purchased. Some are specifically made for ADA compliance, and literally some of them have zero tolerance, meaning it would have to be installed exactly at 29 in order to hit 34 and to be able to have this knee space back in here. So that the knee clearance is also measured. And so if you don't get the right bowl, you don't have the knee clearance, even though you might be set at 34. But I really don't like that when they pick out a fixture that has 0 tolerances, because you'd have to hit right at 29 in order to get 34. But if they do, it's not that it's not constructible. You just have to really be paying attention in order to get it right. And it says that the P-trap offset from fixture center line, and a lot of times you see these wrapped with insulation, so they can't burn them. Also, you have ones where you have a countertop right here, and so the countertop, rather than like a wall mount lavatory, you could have a countertop, and that countertop has to be at a certain height, and then you might have a undermount sink, and then this 17-inch minimum dimension here matters. Let me see what my cheat sheet says. It's 17 to 25 is what my cheat sheet says this can be. So anyway, that's another one to pay attention to. Got the anyway, it's hard to describe exactly how this, you have to pay attention to it. So this one's a good deal because you have, oh, what was it? I can never remember all these dimensions. Other people are good. 29 to 34 right here. And that would be a nice one to have because look, there's a lot of room to move up and down where you're not just right stuck at the 29 to 34 dimensions. It can be really a challenge when the floor's sloping to a drain and not have ADA compliance problems. Yeah, the handles have to be like that kind of handle. It'd be a one-hand operation. Okay. Now we're getting into bathtubs. And so what do we have here? We have a seat and the grab bars are all dimensioned out, and the distance from the lavatory space still has to be 30 inches, and clear floor space, all that kind of stuff. The 60-inch dimension. So a whole bunch of stuff when it's requiring a seat or ADA bathtub right there. This one we've got a seat up here. And so some of the things that matter, these seats, when it's like that, and it's resting on the tub itself, are not a big deal. Some of these seats are like kind of cantilevered out there and not resting on anything. Hopefully I have a picture of one here in a minute. Let me look. Yeah, let's look at that next one. Yeah, check that out. So we're in a shower in this time, but you can have these in the bathtub a little bit. Nah, I take that back. We've only seen them in the shower. But imagine the torque on the wall right there by sitting here when this is like cantilevered. So what's behind here matters a lot. So you don't have to come back for warranty, and somebody can actually make this functional and use. Really, really matters. You got all these faucet control dimensions you have to really pay attention to. And it's going to be such a nightmare when They're not being paid attention to. And I keep saying that. You got to pay attention to it. And I'm talking about it because it is a big deal. All these little dimensions and stuff, if you're in the right building environment, are really going to matter. And it is worthwhile to, one, coordinate it in advance, make sure people know, make sure people have things like this that are up to date, and that we're checking it. And some of it has, like I said, has to be done way in advance. Like this, the backing for that, it's a big deal. The ability for not having lips to get in and out is also, I don't, let's see if my cheat sheet has that. One half inch is what it's saying that lip can be on my cheat sheet. So the floor level to the height of that can't raise more than a half inch right there. And we got a kitchen sink here, not a bathroom sink, but it's still the same thing, 29 to 34, and still having to try and keep that clear space for knees and stuff, and the counter matters. And it can be a real challenge again, enough to bring up, worthwhile talking about it. And then drinking fountains is another one that's ADA compliance, and most of these I think are pretty. I don't know if I can think of any that. The only thing I've ever really seen is that these aren't installed at the right height. Not that we've ever had a problem with 17 and 19. But this is interesting too, that if it's like you have a wall coming in, let me zoom in. If you have a wall and it kind of recesses back for this this water cooler or drinking fountain, that you have to have an amount of clear space around it. And I hope you can imagine why, but it would make sense to have this in an alcove so people can maybe get by in a uh, really busy corridor or hall or something. But then paying close attention to the clear space, the minimum 30-inch clear space surrounding that is a big deal. Okay, looking at a set of drawings here, we've got where do we find the ADA compliance information for a larger set of drawings, right? So like I said before, we probably wouldn't find ADA stuff on a single family home, but you would on multifamily. They might not have a detailed page for smaller like multifamily stuff, but they would for sometimes the city actually gets involved. If they don't have it, can't get a permit on even some of the smaller multifamily, like a series of condos or something like that, where they'll say, no, you have to have some percentage of these need to be ADA, what's the right word? Convertible, I think maybe might be the right word. But in this case, we're just going to use the larger set of drawings. We've been using this set of drawings for a long time. And where would we find information regarding? Well, the architect does them usually, and almost always they're in the general set. And you can see typical ANSI accessibility standards. They didn't list ADA because ANSI is also part of it. But and let's just take a trip through it. Maybe we should start in. Well, that is the start. So I've got this changes in floor level issue, and air like pathway, and they've got doors, all kinds of door stuff here, ramps and landings. Now we're getting into this guy here, toilets and toilet compartments, and we just looked at these in in the I think you did a better job. Look, 17 to 19. My graphic on the PowerPoint didn't have all that. And they've got the 36-inch clear, and yeah, they've done a better job than my graphics on my PowerPoint. Yeah, 16 to 18 again, 60 inches, again 60 inches. So basically that circle that you see, that 5 feet, I'm gonna go try and find some of those in the drawings where you can see like these square spaces or the circle spaces, and you know, oh, that's ADA. We gotta pay attention. Not that you don't have to pay attention all over the place. Hopefully you can see all these little things. You got showers and stuff right here. A whole bunch of bench details. I think they've done a good job on these from what I've seen so far. I've got the fountain drink options there. Handrails, doors. Got some accessible routes right here. How to reach stuff like outlets and thermostats and other things like that. 48. So where to find it, again, back to set of drawings. Almost always there's a set of in the G. And then let's go to the architectural and let's go to the floor plan. And let's just see what we can find when it comes to, okay. Right there. Do you see that square right there? Almost always that kind of stuff means, hey, this is the space we need right there. But that could be a refrigerator. But that's the kind of thing I'm looking for. As you can tell, this maybe wasn't the best planned out idea. I just kind of jumped into the drawing, see if I could find some for you. Well, let's try this one. Let's try this B3403. Oh, yeah, there we go. That's what I was looking for. Like, you see these circles? Architects saying, yeah, they got plenty of room to turn around right there. And then 1'6", 1'6". For sure, this one's the ADA compliant one. It's got all the grab bars and stuff. This one's also got grab bars, so this one's even bigger. And so when they start detailing these ones out, okay, well, we got to pay attention to those for sure. If there's a problem, now we need to shift things out an inch or half inch or something. Don't do it in these two. You could do it in something over there maybe. Look, there's one right there. So they gave 30 inches typical, but that was already ADA requirement. Yeah, they've got in the shower, they got a grab bar, they got a shower seat. So anyway, you'll find these in the all over the place in the drawings. So they're there when the designers have to plan it out. Hopefully that was helpful. All right, end of slideshow. Oh man, that was an hour and 13 minutes of me talking about uh, plumbing fixtures and ADA. I'm sorry, I was maybe should have done that a while ago. Maybe I should have spread it out because that was brutal. Hopefully you got through that one, and we'll talk to you later.